Okay. First off, you need to know how to name them. Because if you can know how to name them, then you can know how to draw them. You know how to draw them, you can name them. That's half the battle, or almost half the battle. And I want to remind people once again, if it's got 3 carbons, what's the prefix for 3? Prop. And the prefix for 4 is but, or but. Remember, it's prop your butt, not butt your prop. Because that seems to be multiple people seem to switch 3 and 4, and some people switch 1 and 2, which remember it's meth, then F. Okay, and so alkenes, what makes an alkene an alkene? I didn't want to put, that's what the question marks are. I didn't want to put the answer up there. It's a double bonded carbon, so now I'll put the double bonded carbons right there. Okay, so the way that you name these, you always go for the longest carbon containing chain, okay, for the root, like the but, the pent, things like that. I've got some examples coming up on another slide. You always give the lowest, if there's only double bonds and single bonds present, even if there's like a methyl group or an alkyl halide group, you always give the lowest number to the double bond, unless there's something that has an oxygen. Right now we've only been dealing with alcohols, but you'll find out when we do aldehydes and carboxylic acids and stuff that oxygens always get top priority. Okay, but otherwise you'd give the double bond priority. You change the ending from ane to ene. And then I'll give an example of what I mean by number 4. But for a cycloalkene, since it's circle, it can go, either clockwise or counterclockwise. So you want to make sure that you give the lower number of the 2 possibilities for the number of locants. And the double bond is always between carbons 1 and 2, unless there's an oxygen present. Okay, because then the alcohol or aldehyde or carboxylic acid or amide or what have you, ester, would get top priority. Okay, so and we'll give some examples of that in just a moment. I've got like a splinter. I don't know how I got a splinter up here on particle board, but I did. So here's some examples. I'll give you a moment to write it down. Or to draw them, I should say. If way early. Her class doesn't start for almost 25 more minutes. Okay. So if we look at at this one. Oh, whoops, didn't mean to do that. Ignore the circle. Sort of like on Wizard of Oz. Pay no attention to the man behind the curtain. Okay. But if we look at this colored one, what's the longest carbon-containing chain? So there's 8, and so that ending would be, or not that ending, that prefix would be what? Oct. And we know the ending for this is going to be octene. And so now we have to give the lowest number to there's only one substituent, and that's the double bond. And so what number would it get? 2. And you only have to give one number to a double bond because the only way you can have a double bond would be to the adjacent carbon. So this would be 2-octene. They put in the hyphen. Octene. Okay. So that one is 2-octene. Now if we look at this colored one, what is the longest carbon containing chain here? 5, and so its root would be pent. And what would the ending be on this one? Ol, because it's got the alcohol there. And so let me attempt to draw this one. So we know that there's a pent. Okay? And we know we have to give something for the double bond. And so what number, unfortunately it hit it, so you have to look at your notes. What number was the double bond on? 1. Because this time the alcohol is directly in the middle. Now if the alcohol was just one carbon further to the right from the way that I have it drawn, then it would not be on carbon number 1. It would have a much higher number, about that carbon number 4, because the alcohol gets top priority. But the alcohol is right in the middle of this one, so it's on number 3. Oh, whoops, kind of give that one away. It's on number 3. So we know it's going to have an ene. Okay, but we've got to give a locant to that ene, and we've already said that was number, not Linton, stupid auto correct. Well, I'm going to change the L in just a moment. So, who would have known that the iPad was Catholic? Okay. So, pen-teen. Oh, it had Pentecostal in there for a moment. We were about to pray it through, I thought. Okay, and we know it's going to have an OL ending, but we have to make sure that we put the locant in. So you have to put the hyphen, the 3, hyphen, and then the ending. This is when you have to do that breaking apart thing. Because we couldn't say 1, 3 pentanol. They just won't do that. So this is 1 pentan, 3 ol. So there we go. All right, and this next one, I'm going to have to draw it out because it's going to be a little bit of a doozy. What's the longest carbon-containing chain here for the root? It's going to be a cyclopentene, right, because it's 5 for that cyclic group. Okay? So we can go ahead and write down the cyclopentene. There's no alcohol on it. And we don't even have to give it a locant, because by default, it has to be carbon number 1, between carbons number 1 and 2. Now, if you said 1 cyclopentene, I'd give it to you, because as long as you didn't give it another number, like if you said it was 3 or 4 or 5, then that would be incorrect. Okay, so we have one cyclopentene or a cyclopentene, but now we have to talk about the functional groups hanging off. We have this one, which is the same as this one right here. What are those? Methyls, and then this one is ethyl. Okay, and so which one comes first in alphabetical order? Ethyl. So it's going to be the very first one listed, because some people are still switching that. But I'm going to start with what comes last, because I never give myself enough room. Okay, so first it's going to move all of it, so never mind. So we have methyl. And what else do we have to put for the methyl? Di. And we have to give it the number, the locants. So what numbers are the methyls going to be on? It's going to be on 3 and 4. And the reason being, let me write it first, and then I'll explain why. The reason being is this one, you always have to have the double bond between carbons number 1 and 2. So if we go 1, 2, 3, 4, 5, it'd be in 4 and 5, it'd be too high. Whereas if we say that this is carbon number 1, it's 1, 2, 3, and 4. Let me see. Oh, well, that's weird that it put those together. And it put that together. All right. So now we have the ethyl, and the ethyl was on carbon 4. So it's 4-ethyl, 3,4-dimethyl cyclopentene. Or you could have said 4-ethyl, 3,4-dimethyl, 1-cyclopentene. Yeah. Oh, it's frozen. It's probably... Well, verbally, I am saying it's 4-ethyl, 3,4-dimethyl cyclopentene. Now I'll pause this. All right, so now we're going to talk a little bit about the physical properties. And so, we want to have our rule of thumb. Go figure, they don't have a little thumb emoticon on here. So I have to make my own. All right, so we have a rule of thumb. And so this is just to remember. If we remember back, methyl groups are electron donating. Okay? It's sort of like having similar like to a slight dipole. And so they did that when we talked about radicals and carbocations. Remember, because the more friends it had, the better off and the more stable it was. And there were two technical terms for that. You know, I always called it more friends. Does anyone remember what the scientific terms was? Hyperconjugation and induction. And so it's hyperconjugation and induction. That's what it can help by. Okay? And so because of that, it's going to change the stability. And we now can talk about, I want you to know the logic behind this in general. And so I made multiple slides for each one of these. Okay? So first off, the stability of the alkene can be due to the degree of substitution. So I'm going to draw two examples here. We have, and I'm going to draw it out the old-fashioned way, so that way it's a little easier to see. So we have that one versus this one. This is when we say substitution, we're substituting carbon-containing groups in place of the hydrogens. Okay, that's the same thing whenever they talk about saturated fats versus non-unsaturated fats. Saturation means it's all hydrogenated. So this would be more saturated than this. And so knowing about hyperconjugation and induction, of the two, which one's going to be more stable? Is it going to be the one that has a more highly substituted or the one that has more hydrogens? The more highly substituted. And so, yep, this one here is more stable than the other one. So the more alkyl groups that are hanging off, the more stable it will be. And once again, it's just because it just helps stabilize that double bond. And then the second major thing that's going to help with the stability is van der Waals strain. And here, that's because they're isomers. Now we're talking about they have the same degree of substitution, but it's called cis and trans. And so what does cis mean? Do you remember? Same. And then trans means it's on opposite. Okay. And so let me draw an example of that. Oops, that's supposed to be a 3. This one. And this one. Give me a moment to get caught up. First off, which one is the cis? The one on the left or the one on the right? Right, it's the one, correct, it's the one on the right. That one's the cis. So by default, the other one has to be trans. Okay, and which one do you suppose is more stable, cis or trans? Trans, because it just has more room. So the methyl groups, the larger groups, they have more room. And it's even more pronounced if this was like a big, 5 containing carbon chain, and on the other side is like 6 containing, because you're just going to see that it's much more room. And I also give you these are really easy to spot whenever they draw it out. like using the little stick model, because if it looks like this, that's a trans, whereas if it looks like this, that's a cis. Whoops, that's supposed to be a double bond. And by the way, that's one of the reasons why trans fats are so bad. We'll get to that later. That's next semester. Or in biochemistry, you talk about it too. And the very last thing I want to do, because we'll get into more about isomers in the next class, but it's just the orbital hybridization. And that's just, once again, I'm just going to draw. So there's a double bond. And if we pointed that one, why won't it let me here? Versus the terminal one. Okay. And so the terminal one, first of all, what shape is that terminal one? There's a carbon in a single bond, so therefore it's what? It's tetrahedral. And so what's its orbital hybridization? It's sp and then 3. Okay? Whereas if it's in a double bond, what's its shape going to be? It's, pardon? Trigonal planar, okay, and its orbital hybridization would be, and it won't let me, there we go, so sp2, yep, so it's just, come on now, you can do it, gotta have like positive self-affirmation. All right, and so that's where we'll end class for today.